Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Fadil Putra Alzori, dan hari ini saya akan mempresentasikan tentang Matrix and ODE in application in Allen's field. Matrix and signal processing. In signal processing, there are different kind of signal processing examples for matrix. For example, there's a signal representation where signals can be represented as vectors or matrices. This allows us to apply mathematical operations to manipulate and analyze them. And there are linear transformation where matrices are used to perform linear transformation on signals. This includes operations like filtering or removing unwanted noise or frequencies from a signal, amplification or attenuation, increasing or decreasing the signal's amplitude, mixing, combining multiple signals, and downsampling or upsampling, changing the sampling rate of a digital signal. There are also feature extraction, where metrics can be used to extract relevant features from signals, which is crucial for tasks like pattern recognition, and identifying specific patterns within a signal, like speech recognition or anomaly detection in sensor data. Classification, assigning a signal to a specific category based on its feature. And there's also signal decomposition, where technique like the discrete Fourier transform or DFT and discrete wavelet transform or DWT use matrices to decompose signals into different frequency component or basis function, respectively. This is essential for analysis and comprehension. ODE in the signal processing. For ODE signal processing, there are filtering. Many filters, especially analog filters, are described by differential equation. The filter's output is the solution to an ODE driven by the input signal. Example, a simple RC resistor capacitor low-pass filter behavior is governed by a first-order ODE. Adaptive filtering is created where the signal characteristic change over time. Adaptive filters adjust their parameters based on the error signal. This adaptation process often involves solving ODEs in real time. Modulation or demodulation. Technique like amplitude modulation (AM) and frequency modulation (FM) involves the use of ODEs to describe the process of encoding information into a carrier signal and extracting it at the receiver. Signal generation. Some types of signals, like sinusoidal or chirp signals, can be generated by solving specific ODEs. Example in noise reduction in sensor data. Let's say you have a sensor measuring temperature, but the readings are contaminated with noise. A common approach is to use a Kalman filter. This involves one, state space model, representing the sensor dynamics or how the true temperature changes, and allows using matrices. Kalman filter equations. There are a set of recursive equations derived from the state space model that estimate the true temperature by combining the noisy sensor readings with the model predictions. 3. Matrix operation. The Kalman filter involves matrix multiplication, inverse, and addition at each time step to update the estimate. That's it for me. Thank you so much, sir, to uh, sudah menonton presentasi saya. Sekian terima kasih dari saya. Wassalamualaikum warahmatullahi wabarakatuh.